Alright, let's dive into the world of Python with some calculator action. We are going to build something that won't just perform everyday math tasks, but can do so efficiently and reliably, a true production-ready calculator. It's all about functionality, security, and performance, folks. But first, let's get one thing straight. We are using Python, the language of simplicity and power, where everything is clear and straightforward, kinda like our friendship. Imagine this: you are working on a critical piece of software. Let's say you are an IT fresher, eager to learn, and now you are tasked to create a calculator that can handle all sorts of numbers, even the big ones, and deliver the results without breaking a sweat. I know, sounds like quite the challenge. First things first, we start by laying down a proper architecture for our calculator. Think of it as the scaffolding that holds everything together. We need a user interface to interact with, right? Let's use Tkinter. It's friendly for beginners yet robust enough for production. We'll also include a robust backend written in Python that processes our calculations. How about this? A function for parsing expressions using the eval function for each operation, wrapped inside try except blocks to catch any pesky errors. But wait, before we get our hands dirty, let's remember we want to make sure our calculator isn't just functional but also secure, safe from nasty things like SQL injection or scripting attacks, which is always paramount. For this, we'll just keep it simple and secure, as we are not directly interacting with databases or executing raw user inputs as code. Python's eval is not used for such things in real-world applications, as a safety precaution. Anyway, here's our function: Python definite calculate, try, result is equal to eval return f result, except exception as e, return str. Pretty neat, huh? But we are not done. We've got to test our calculator's mettle. So, performance testing is on the agenda. And don't worry, we'll also look at security enhancements and ensure our operations are handled correctly. Oh, and let's not forget our scalability strategy. Imagine we are looking to grow our calculator into the enterprise-level solution. Maybe integrate with a cloud storage for scalability or optimize our calculations for performance. Remember that we might need to handle floating point operations, or perhaps introduce a caching layer with something as simple as a dictionary to store frequently used results. This ensures our calculator isn't recalculating answers that have already been crunched. Say we want to make sure it doesn't just work locally, let's look into deploying it to a service like Heroku or using Python Anywhere for hosting. Deploying code is a piece of cake with tools available in the Python ecosystem, like Docker for containerization and Flask, a micro web framework, to serve our calculator as a web application. As we wrap this all up, security can't be left to chance. Let's implement input validation to avoid errors from unexpected data, keeping in mind a good logging system that can record any unusual activities without impacting our database's performance. But here's the kicker: we should not end our exploration here. Python is vast, and there are so many opportunities to iterate, enhance, and even extend functionality, maybe adding support for more complex mathematical functions or user configurability. And how about we take it one step further and write some unit tests with Unitest or PyTest frameworks? That'll ensure our math doesn't let us down, even as we grow and evolve this project. Finally, to keep up with the latest practices and to refine our skills, let's explore some resources like the Python Software Foundation's official documentation, Python enhancement proposals, and join communities like pythontutor.org. Learning never stops, and neither does the joy of coding along with a friend. Now that you've got the gist of taking our simple calculator to heart, the realization dawns upon us while we've crafted a sturdy foundation. The true beauty lies in the conversation it invokes, the hands-on experience it offers, and the community we become part of, all with a simple yet powerful language like Python. And hey, if you want to keep chatting about code, join the TechLab, a little corner on this internet universe where we discuss and share Python knowledge, get tips, or find a nugget of wisdom we can apply to our own projects. Let's visit neeraj.qz.io and subscribe to TechLab. What do you say? The adventure into production-ready calculators and, in essence, productivity begins now. Visit neeraj.qz.io and subscribe to TechLab.